This is the second lesson of our Induction to AS Maths, the crossover between GCSE and AS level. We'll start just by if we can recap what you did before. So push pause while you sketch these graphs, straight line graphs, and you have to try and find out where they cross both axes like I did at the end of the last one. So push pause now. And I'll show you the answers then. So this one here, we know it's going to cross the y-axis from our GCSE work at 1. We know here we've got a 3, the gradient is 3, so we know it's going up. The extra bit that we've got to find out is we need to find out this value here as well. So we write 0 equals 3x add 1, take away the 1 and divide by 3, and x is minus a third. And that makes sense because the minus a third, it's to the left of the axis there. And so there's our first one. Second one, same sort of idea. We know from our GCSE work that it's going to cross at 9. Let's put the 9 up there. And we know from our GCSE work that it's a going down one because you've got a negative gradient. So it's going down like this. So this answer here I'm expected to be positive this time. Let's find it out. 0 equals 9 take away 2 x's. Add the 2 x's and divide by 2. I'm going to write 9 over 2. You're still thinking about 4.5, aren't you? But I'm just writing 9 over 2. On the third one, this time the gradient is just the number of x's here, which is a half. It's still going up, but not very quickly. And it's crossing here at 3 from that one there. So it's going up slowly, crossing through 3. That value there turns out to be minus 6. I've now written this one in a slightly different way, and some of my class might want to do tables of values to try and figure it out, but what you really need to do is make this a y all on its own. The issue is we've got this 2 here, so you've got to divide everything by 2. So if we divide everything by 2, we've got a half of x there, and we've got 6 divided by 2 is 3. Oh look, we've just done that one. These two were both exactly the same, it was just a different way of writing it. And that's leading us on to this next one here, which I'm going to do on the next screen, about showing you with lines that are when they're slightly written in a different way. Homework dates were for my class, yours will be reasonably similar, but here's this one about written in a different way. Like we did at the end of the last lesson, there are a couple of places here. This point here, this axis here is when y equals 0. And the other way round, this axis here crosses through the value when x is equal to 0. So if you put a 0 into there, that's just going to be 0. And you're left with 2y minus 6 is 0. Add the 6 to both sides and divide by 2 tells us that the y value here must be 3. Let's do the same for the other one. If I put y equals 0 in, that means this thing here is going to be 0. What's left is 3x minus 6 equals 0. Add the 6 and divide by 3 gives me that x is 2. Here's my x is 2. Having got these 2 points, I can now join them up, and there's my straight line, crossing through 3. And it's clearly going downwards. The other way that we could have done that, I think I'm going to do it on the next screen actually, is to actually rearrange it. So if I wanted to rearrange this to get these y's all on their own, first of all I'm going to have to add that 6 on, aren't I? Let's add 6 to both sides. I could even write down the side here that that's what I just did. Now I want to get rid of those x's from that side, and so I'll write 2y equals 6, take away 3 x's. And finally, I'm now going to divide by 2. So when I divide by 2, I've got 3 take away, and again, look at this, just 3 over 2. Don't need to write 1.5. 3 take away 3 over 2 x's. That tells us, of course, it crosses at 3, and it's going down with a gradient of 1.5. Go back a second and see, look there. It was crossing at 3, and it was going down with a gradient of 1.5. So for the next little part, could you rearrange each of these into y equals mx plus c form to find out what their gradient is, and then sketch each one parallel lines. We had in lesson 1, we had a straight line here that had a gradient of 2, and there was another one down here that also had a gradient of 2. And I suggested that these two were linked by a certain word, and the word was parallel. The big thing you need to remember is that for parallel lines, their gradients are always the same. So which of these are parallel to the base one here? It means knowing what the gradient of this is. The gradient of this is clearly 3 because we got the number of x's. But none of these are in quite the right form to see that. This one, we've got to divide by that 2. And so that would give us y equals 9 divided by 2 plus 6 divided, I can do 6 divided by 2. 6 divided by 2 is 3. So that one's got a gradient of 3. Yay. It is parallel to that one. This one here, I want to get the y all on its own. So I just want to add those 3 x's. So that says 10, add 3 x's. And the gradient of that one is 3. Yay. That one's parallel as well. Did I do all 3 of them? Let's find out. This one, I want to get the y all on its own, so I need to take off that 15 and take off those 3 x's. So I've got minus 15 minus 3 x's. So we've got a 3. No, it's a minus 3. So the gradient of this one was minus 3. So that is not parallel. You could try that from the book. It takes about 10 minutes in class, and there's other exercises as well. So 4, 6 and 7 are the essential ones, but you can try other ones too to try and see if you can get those. Perpendicular. Well, perpendicular lines are lines that meet at 90 degrees. These two lines here meet at 90 degrees, so they're called perpendicular. Let's have a look at their gradients. This one here is going 2 along and 1 up, so that one's got a gradient of a half. Now this one here meets it at 90 degrees, and this is going 1 along and 2 down, so it's minus 2. This line here is going 1 along and 2 up. That's got a gradient of 2. And this one here meets it at 90 degrees. That's going sort of 2 along and 1 down. So that's got a gradient of minus a half. Your job's to try and spot the link between these two numbers. Let's see if you can get the second one before I do it. This one here is going 1 along and 3 up. So this one's got a gradient of 3. What do you think this one here that meets at 90 degrees is going to be? Well, look, it's going 3 along and 1 down, so it's minus 1/3. They always seem to be positive and negative, don't they? One of them seems to be a fraction each time. This one here, that's a horrible gradient, that one there, isn't it? Well, let's pick that point there and that one there. Seems to be going 1 along and 1, 2, 3, 4 up. That one there's got a gradient of 4. Think it's going to be negative something? Well, it's going down, isn't it? In 90 degrees, 1, 2, 3. It's going 4 along and 1 down. So that's minus a quarter. 4's going to minus a quarter. And most people have spotted the link by now, that if one gradient, we use m for gradient, the other gradient is the fraction 1 over m. And so I'm going to go around the room now and ask people, well, if this gradient is 6, what's this one? Minus a 6. If this gradient is minus 3, then what's this gradient? Minus 1 over minus 3. Well, that's a third, isn't it? And then I'll ask something about 2/3 as well. And the 2/3, 1 over 2/3, is a big discussion point. We know it's negative. But when you do 1 over a fraction, what happens to it? And we'll talk more about that, how it goes to minus 3 over 2. Again, that's why we talked about using fractions rather than decimals. If I've got a gradient of 1.25, I don't know what that one's going to be. But if I said, no, this is 5 over 4, then this one here is going to be minus 4 over 5. Much quicker and easier to work with. with fractions. Find a line that's perpendicular to this one then. So job one is we need to know what the gradient of this one is. So like we've been doing a few times, let's rearrange it to get y all on its own. We'll divide by 3 here. So this one's gradient is minus 2/3. And so the perpendicular gradient that we want is going to be minus 1 over minus 2/3. And that's 3/2. So it says find a line, and we want any line then. So we just have minus 3/2x. That will do. But you could put a number on the end, or you could put any number on the end if you wanted to, or whatever number you like. But the important bit is that the gradient must be 3/2. It's another exercise to do. Oh, it's just more of the same one, finishing off the questions 8, 9 and 10 from the first exercise in the Core 1 textbook. And that's the end of our second lesson.